Today we need to start with symmetric algorithm with block and stream ciphers. Now see, the two main types of symmetric algorithms are block ciphers, which works on block of bits, and stream ciphers, which works on one bit at a time. Now see, as you people are well aware about the term symmetric algorithms are those algorithms which works on a single key. I mean to say that the instance of a single key would be shared between sender and the receiver, and that key has to be transferred from sender to the receiver in order to encrypt and decrypt the data that we have discussed regarding the symmetric algorithms. And what were the advantages of symmetric algorithm? They are much faster, they are less complex. But what were the disadvantages? Disadvantages were the key distribution is overwhelming, right? Because if you have more than 2 users or like 100 or 200 users, thousands of keys are required to distribute among multiple users. So this is a very bit difficult process to secure the keys in this particular scenario, right? So symmetric algorithms require to block and stream ciphers. So block and stream ciphers are the types of symmetric algorithms, right? So you have to assume that they must be using the single key, right, at the sender and the receiver side, and they are faster and all these things. So block and stream ciphers are the types of symmetric cipher. So we have to look one by one over a block cipher and stream cipher. So first of all, I would like to explain you on slide number 3 regarding the block ciphers. When a block cipher is used for encryption and decryption purposes, the message is divided into block of bits. These blocks are then put through a mathematical functions, one block at a time. Suppose you need to encrypt a message you are sending to your friend and you are using a block cipher that might use a 64-bit. Your message of 640-bit is chopped up into 10 individual block of 64 bits. Now see, when we are talking about a block cipher in symmetric algorithms, how they work. Actually, your data or your information is being divided into a set of blocks. An individual block is being operated by a certain sort of encryption algorithm, right? And then that data would be sent in blocks to a receiver, and at the receiver's end, those blocks would be decrypted accordingly at the receiver side. This is how your block cipher works. Now, as you can see in the last slide, last line, like suppose you need to encrypt a message you are sending to your friend, and they might be using a block cipher that uses 64-bit. Now, let's suppose if you need to send some information to your friend, and the block size that you are using of 64-bit, and the total message size is 640 bits, right? Then how many blocks would be created? 10 individual blocks, right? Now these 10 individual blocks would be encrypted accordingly and then sent accordingly to the receiver, and receiver might be decrypting each one of the block according to the instructions which were been given at the sender's end, and the whole process is being going on. This is the basic idea of a block cipher, right? So each block is put through a succession of mathematical formulas, and what you end up with is 10 blocks of encrypted text. You send this encrypted message to your friend. He has to have the same block cipher and key, and those 10 ciphers blocks go through back through the algorithm in the reverse sequence and end up in your plain text message. That I have told you just now, that the same 10 blocks of data would be sent to the receiver. Receiver has to reverse engineer the same cipher text, I mean 10 blocks of cipher text, and will find out the plain text from those particular 10 cipher text values, right? So this is how your, I mean to say that block ciphers works, right? I mean how this block cipher, I mean to say that working procedure is going on, right? So this is how, this is what regarding the block ciphers, right? Now this is the diagram that I need to explain you. I mean, let's suppose you have a message that is called as your text message. It has been converted into a binary numbers. That is the set of blocks. I mean, I think they are the 5 blocks that have been created from the given text message. Now, your crypto system would take each one of the block and perform encryption over in each block, right? Now, let's see in this particular diagram. This is the first block of plain text. Encryption is being applied, and your first block of ciphertext would be created from this plain text. In the same way, your second block of plain text would be taken, encryption is applied, and you would be getting your second block of ciphertext. In the same way, you have the third block of plain text, encrypted, and then you have the third block of ciphertext. This is how your block cipher diagram or block cipher mechanism is being worked, right? Then a strong cipher contains the right level of two main attributes. One is called as confusion, and another one is called as diffusion. So confusion is commonly carried out through substitution, while diffusion is carried out by sensing by using transposition. I have already told you regarding the substitution and transpositions are the basic building block of any type of encryption, right? I mean to say that, symmetric algorithm that we have discussed in our previous lectures. Substitution is what, as you are going to substitute different words with different bits with another set of different bits, like Caesar ciphers, right? We are just moving bits around, three words around or three words back, three characters around forward or three characters backward, and then we substitute a new word over there. This is how we are going to apply substitution procedure over our given plain text, right? Another one is called as your transposition. Transposition is the mechanism in which you are going to jumble up the information that you have already transposed, right? This is what you can call it as transposition. So confusion correlate with substitution, and diffusion is correlate with your transposition. So that's what we need to learn in this particular scenario, like in block ciphers. Okay, confusion and diffusion are being used in order to encrypt the information, right? So for a cipher to be considered strong, it must contain both of these attributes. To ensure that, reverse engineering is basically impossible. The randomness of the key value and the complexity of the mathematical function dictate the level of confusion and diffusion involved. Now see, you need to, let's suppose if you want to make your cipher more strong, how can you make it? You need to include both mechanisms. I mean to say that your confusion as well as your diffusion, both the mechanisms are being involved or implied during this procedure, and this is very difficult for an attacker to reverse engineer this particular process. And the randomness of the key, as you know that this is a symmetric algorithm, there is an instance of a key that is being used at the sender as well as at the receiver, that is a single key. So randomness of key and the complexity of the mathematical function, these are the two things which are going to show us the level of confusion and diffusion involved, right? This is how you're going to make a good, stronger cipher from the given set of values, right? So now this is an example of a confusion and diffusion, right? Now let's suppose we have the 500 wooden block which are being which contain certain sort of letters, right, like in Scrabble. So they what they have done, they lie them up or line them up and spell out a paragraph. There are certain ABC words are being written over a certain set of blocks, and they are going to pile them up in a row so that it shows certain sort of paragraph or text, right? What they have done, they have substituted 300 of them with another set of 300 blocks. What they have done, they have substitution, they have applied substitution. In this scenario, this is being called as confusion. Confusion through substitution is being applied because you have substituted the 300 words with another 300 words in order to make your information secret, right? Then I scrambled up all of these blocks. This is what you can call it as diffusion through transposition, and leave them in a pile. Now see, in the first step, we have applied substitution, which is also called confusion in this particular scenario. And in second step, when we have applied substitution, now that substituted text again be jumbled up in the form of transposition, or you may call it as a diffusion, so that your cipher would make it more stronger, or your text would make it more stronger, and it would be very difficult to be recovered from a given set of values. So for you to figure out the original message, you would have to substitute the correct blocks and then put them back in the right order. Now if you want to recover that particular substitution and transposition, first of all, you have to substitute the correct words. You have to line them up, and then you have to again put them back in the right order as you know the key, like that, right? So this is how your confusion and diffusion example is being explained in terms of block ciphers, right? Then we have the confusion. As I already have told you, confusion pertains to making the relationship between the key and resulting ciphertext as complex as possible, so the key cannot be uncovered from the ciphertext. and each ciphertext value should depend upon several parts of the key. But this mapping between the key value and the ciphertext values should seem completely random to the observer. Now see, I have told you that key is dependent upon the ciphertext and ciphertext is being dependent upon the key. So the randomness between the key and ciphertext is very important, and there must not be any relation between the key and the ciphertext. But if there is some relationship, someone has found some relationship between the key and ciphertext, it would easily break up that particular algorithm, right? So you must have to that is in the last line what he has written. The values should seem completely random to the observer. The value of key value and the ciphertext value, there must not be any relationship between them, so that if there is some relationship between them, if the patterns are being matched, then easily some observer or some attacker can find the values or find the actual key value or the ciphertext value, plain text value from the given scenario. So this is how we are going to apply the confusion mechanism, right? Then we have the diffusion. Diffusion or transposition means that a single plain text bit has influence over several of the ciphertext bits, right? I mean to say that uh, in the diffusion procedure, what we have means that a single plain text bit has influence over several of the ciphertext bits. Changing a plain text value should change many ciphertext values, not just one. So in fact, in a strong block cipher, if one plain text bit is changed, it will change every ciphertext bit with the probability of 50%. This means that if one plain text bit changes, then about half of the ciphertext bits will change. Now when we apply diffusion, diffusion is something to jumbled up the information, right? So what, according to the diffusion definition, what you need to do, your relationship between your plain text and ciphertext would be considered in such a way that if you are going to change any one of the bit in your plain text, 50% of the text of your ciphertext is going to be changed. This is a good relationship. This means that you have applied a diffusion in a very good way, right? So this is the scenario that if single bit is being changed in the plain text, 50% has been changed in your ciphertext value, right? So this is the basic definition or basic mechanism of your confusion and your diffusion, which actually previously called as your transposition and substitution. Sorry, substitution and transposition, right? Now, examples of a block cipher. Now how the block cipher works. Block cipher uses diffusion and confusion on their methods. Now it's very clear कि block ciphers जो आपके होते हैं, they might use the diffusion and confusion techniques over their methods. In their methods, the figure shows a conceptual example of a simplistic block cipher. Now there are three steps that are being written in the blue slide. It has 4 block inputs and each block is made up of 4 bits. अब हम समझने जा रहे हैं कि आपका ब्लॉक साइफर काम कैसे करता है. ठीक है, in a very start we have the 4 block inputs and each block is made up of 4 bits, right? Second point is the block algorithm has 2 layers of 4 bits, substitution boxes called X boxes, right? Each S box contains a lookup table used by the algorithm as instructions on how the bits should be encrypted. Now, I can explain you this explanation in my next slide. In the diagram. So you have the message plain text that is called as YX. Now we need to have a blocks. We need to apply a block cipher over this particular situation or over this particular information, right? Now see, there are the concept of S box. अब आपने ये चीज समझनी है कि एक तो ये आपके पास है symmetric algorithm. ठीक है, block ciphers are the type of symmetric algorithm. अगर symmetric algorithm है तो it must be clear that कि they might be using the keys. ठीक है जी, आपके पास ये की यूज कर रहे होंगे, सिंगल की दैट इज बीइंग यूज्ड एट द सेंडर एज वेल एज एट द रिसीवर, राइट? दिस इज आल्सो वेरी क्लियर. सो ऑन द लेफ्ट हैंड साइड इफ यू कैन सी, की डिटरमाइंस व्हिच एस बॉक्सेस आर यूज्ड एंड हाउ. अब की जो आपके पास होगी वो डिटरमाइन करेगी कि आपके पास एस बॉक्सेस को हमने किस मैकेनिज्म के तौर पे इस्तेमाल करना है, ये यूज करना है. ठीक है. सेकेंडली ऑन द राइट हैंड साइड इफ यू कैन सी, you might have the lookup table. अब S boxes के अंदर क्या है? Actually S box is a sort of function which is going to perform certain sort of transpositions and substitution or confusion and diffusion inside that particular box. ठीक है, जैसे जावा की हमारे पास एक क्लास होती है ना, उस क्लास के अंदर different methods होते हैं. Now these methods contains the logic of your code. ठीक है, और उसके अंदर different parameter list आ रही होती है. So parameter list would be your bits which are coming or your data, and the code that is being written inside that particular function that is going to apply it over that particular variables, and they process that particular thing, and then the result would be sent to a calling program. This is how your Java program or function works. The same applies to over here. ठीक है जी, आपका जो S box है ना, वो एक किस्म का फंक्शन है जो आपके पास सब्स्टिट्यूशन और ट्रांसपोजिशन परफॉर्म करके आपके डेटा को encrypt करता है. ठीक है, now in this particular scenarios we have divided our data into 4 different blocks and each block is containing 4 different bits. ठीक है जी, अब आपका डेटा S box में जाएगा, वो substitute और transpose होगा, then निकलेगा, again it will go to another S box, it will again substitute and transpose, and finally your data would be coming in the form of encrypted message that is called as your cipher text. एक चीज अंडरस्टैंड करने की है यहाँ पे कि what is substitution and transposition? Confusion and diffusion. Why we apply confusion and diffusion over our plain text? Because we need to encrypt. और encrypt करने के लिए हम या तो अपनी bits की numbers change करते हैं, या फिर हम secondly हम क्या करते हैं कि we are going to to say that diffusion, हम jumbled up करते हैं information को, so that the third person cannot understand what the information is being transmitted over a network, right? But if right now we are using the two text S boxes ना currently, right? लेकिन अगर हम इस तरह की layers 3 या 4 layers और add कर दें इस पूरे scenario के अंदर, now as many layers as that you are going to add in between, the more data, your data would be more secure because more substitutions and transpositions would be occurred and your data would be more secured. ठीक है जी, और वो ज्यादा जंबल्ड अप और ट्रांसपोज्ड होगा जिसकी वजह से उसको डिक्रिप्ट करना उतना ही मुश्किल होगा, राइट? सो इन दिस पर्टिकुलर सिनेरियो इफ यू कैन सी द टेक्स्ट दैट हैज बीन रिटन एट द लोअर एंड ऑफ दिस पर्टिकुलर स्लाइड, अ मैसेज इज डिवाइडेड इनटू ब्लॉक्स ऑफ बिट्स and substitutions and transposition functions are performed over these particular blocks, right? So the S boxes are, the figure shows that the key dictates what S boxes are to be used when scrambling the original message from readable plain text to encrypted non-readable cipher text. Each S box contains the different substitutions method that can be performed on each block. So this example is simplistic. Most block ciphers work with block of 32, 64 or 128 bit in size, and many more S boxes are usually involved. Now see, I have told you the basic definition कि S box करता क्या है. ठीक है, तो पहले दो points जो हैं वो S box को explain कर रहे हैं. The last blue text is going to explain. Right now we just only use the 4-bit block, but actually this is so simple, but actually the algorithms are using the complex sort of S blocks, right? They might be using 32-bit, 64-bit or 128-bit in size. So when you are going to apply substitution and transposition mechanism over these particular bits, so you would be getting more jumbled and transposed information inside your encrypted text, right? We don't have time, तो इसलिए मैं, क्योंकि 29 स्लाइड्स हैं और आज हमने ये चैप्टर खत्म करना है. स्ट्रीम साइफर्स आर, I would like to give you an example कि जी स्ट्रीम साइफर इज समथिंग व्हिच वर्क्स ऑन बिट बाय बिट. ब्लॉक साइफर में क्या होता था? ब्लॉक साइफर में you have a complete block and that block is going to be encrypted and then decrypted and all that. Your data is being divided into blocks, but in stream ciphers what is going to be happen, each bit by bit encryption is being applied over the stream ciphers, and then you would be getting the resulting cipher text based on individual bit, right? This is what the basic idea of a stream is, right? So when using a stream cipher, a plain text bit will be transformed into a different cipher text bit each time it is encrypted, right? इसका मतलब यही है कि एक bit उठाएंगे, उसको किसी की के साथ मिलाएंगे, and then you would be getting a new text value. Now how this procedure is being applied? Stream cipher uses a key stream generator which produces a stream of bit that is XORed with the plain text bit to produce cipher text as shown in the figure. ये चीज आपको क्लियर होगी नेक्स्ट डायग्राम में. In this particular diagram you can have more explanation to that particular concept. I mean, देखें, अब एक की स्ट्रीम जनरेटर है जो आपके पास रैंडम बिट्स जनरेट कर रहा है, ठीक है, बट मेक श्योर योर की स्ट्रीम जनरेटर हैज टू जनरेट द बिट्स इन सच अ वे दैट इट मस्ट नॉट बी जनरेटिंग एनी टाइप ऑफ पैटर्न. पैटर्न का आप लोगों को पता है कि इस तरह से नहीं होना चाहिए कि 4 बिट्स जनरेट की, 1 4 zeros 4 1 and 4 zeros. That must not be the case. So if such patterns are being generated, your invader can easily disclose those patterns और फिर आपकी information जो है वो compromise हो जाती है, right? So it is very important your key stream generator must generate some sort of randomly based bits, right? And then you have a plain text message in the form of bits. Both are being XORed. I mean आपकी की स्ट्रीम की जो जनरेटर की बिट्स आ रही हैं और आपका जो प्लेन टेक्स्ट है वो दोनों XOR होंगे and you would be getting a cipher text. This is how your stream cipher works, right? So with stream ciphers, the bits generated by the key stream generator are XORed with the bits of the plain text message, right? So this is the basic ideology of your stream ciphers. So what is the relationship between a one-time pad? I have told you that your one-time pad किस तरह से मैंने mechanism perform करता है. You have the text value, you have the equal bits of one-time pad, both are being XORed, and the resulting value would be your, I mean to say that the cipher text, right? The same applies over here. यहाँ पे situation थोड़ी सी different ये है कि you have the key stream, right? And which is going to generate bit by bit value, and you have the plain text which is also been in the form of bit by bit value. I mean both the values are being XORed one by one, and the resulting text value or the cipher text would be generated. So this is just the similarity between the one-time pad and your stream cipher, right? So functions of key in stream ciphers. If the crypto system were only dependent upon the symmetric stream algorithms, an attacker could get a copy of the plain text and the resulting cipher text, XOR with them together and find the key stream to use in decrypting other messages. So the smart people decided to stick a key into the mix. Now see, I mean, आपने एक की स्ट्रीम जनरेटर के साथ जो वैल्यू जनरेट की, ठीक है जी, प्लेन टेक्स्ट अगर किसी को मिल गया और आपके पास साइफर टेक्स्ट किसी को मिल गया, अगर उन दोनों को अगर आप XOR करेंगे तो you would be getting again your key stream generator, and once you got the key stream, so by using that particular key stream you can decrypt any of the information that is coming in the future. So in order to I mean overcome this particular situation, you need to add certain sort of information with your key stream so that it is going to randomize the information. ठीक है, तो वो हमारे पास क्या होती है, that is your key, right? So in block ciphers, it is the key that determines what functions are applied to the plain text and in what order. The key provides the randomness of the encryption process. So what we have to decide, what we have done in the block ciphers, your block ciphers are going to be randomized based on your keys. I have told you that. ठीक है, आपकी जो key होती है, that is going to add randomization inside your I mean to say that solution. So as stated earlier, most encryption algorithms are public, so people know how they work. The secret ingredients is the key. And according to Kirchhoff's law, we know that your algorithm must be public, but the thing that is being private is called as your key. So we need to make our key private. So that's why your key is the basic ingredient in order to I mean include randomization. So in stream ciphers, the key also provide randomness so that the stream of bits that is XORed to the plain text is as random as possible. तो अब stream ciphers के अंदर भी आपके पास जो difference पैदा करेगी value के अंदर, that would be your key. I mean you need to attach key with your key stream, and then that is going to make it different from the other algorithms. Now see, this is the diagram. अब देखें, अगर आप की को हटा दें तो in previous diagram the same situation was there. I mean your key stream generator would be generating the bits. आपका plain text left से आ रहा है, both are being XORed, and the ciphertext would be generated. अब इसमें लिमिटेशन क्या थी कि अगर किसी को ciphertext मिल गया और plain text मिल गया तो वो जोर करके आपकी की स्ट्रीम जनरेटर निकाल लेगा, की स्ट्रीम निकाल लेगा और उस की स्ट्रीम को यूज करते हुए वो किसी भी टेक्स्ट को डिसाइफर कर सकता है। ठीक है, अब इस चीज को ओवरकम करने के लिए अकॉर्डिंग टू सिमेट्रिक एल्गोरिथम की इज बीइंग यूज्ड एट द बोथ एंड्स। So we are going to add key with the key stream. It is going to randomize the value and the resulting text or the cipher text would be very difficult to decipher because key would be only lying down with the person who is the sender and the receiver. In between किसी के पास नहीं होगी। ठीक है, so this is how you are going to add certain value to your key stream ciphers, right? But again, if you think that you need to make your system more stronger, you need to add the initialization vector too. Now see, what is the initialization vector? Initialization vectors are random values that are being used with algorithms to ensure patterns are not created during the encryption process. Now see, this is an extra sort of security that you are providing to your system. I mean, IVs are certain sort of random values which are being added to your algorithm in order to ensure the सिमिलर पैटर्न्स मस्ट नॉट बी क्रिएटेड। ठीक है, अगर आपके अटैकर को पैटर्न्स का पता चल गया ना कि जी ये चीज आपके पास रिपीट होती जा रही है, ठीक है, तो ही कैन इजीली break your or compromise your algorithm. So they are used with keys and do not need to be encrypted when being sent to the destination. अब keys के साथ हम क्या करते हैं, IVs भी include कर लेते हैं. These are the certain values which are being added with the key and going to randomize your solution. Going to randomize more your situation or your solution, right? So if IVs are not used, then two identical plain text values that are encrypted with the same key will create the same ciphertext, right? Now see, अब देखें, आपका की स्ट्रीम था, आपका प्लेन टेक्स्ट था, आपका साइफर टेक्स्ट जनरेट हो रहा था, ठीक है, दिस इज द फर्स्ट सिचुएशन दैट वी हैव रेड सो फॉर। अब अगर किसी को प्लेन टेक्स्ट मिला और किसी ने साइफर टेक्स्ट उठाया, उन दोनों को कंबाइन करके इट वुड बी जनरेटिंग अ की stream value, ठीक है, and by using that particular key stream value it can easily deduce the information. That is the first situation. इसको overcome करने के लिए हमने क्या किया, we have added key to the key stream, ठीक है। अब key से क्या हुआ, आपके पास क्योंकि key is only lying down with sender and receiver, तो it is more secure now, ठीक है। अब आपकी values randomize हो गई, अब कोई बंदा उसको नहीं ले सकता, लेकिन still there is a problem. Problem कहां पर है कि if your key that is going to be generated, जाहिर सी बात है की स्पेस से की जनरेट होगी ना। अब अगर आफ्टर 10 और 15 टाइम्स सेम की इज बीइंग जनरेटेड, ठीक है, और की स्ट्रीम भी आपके पास सेम है, अगर वो की स्ट्रीम और आपके पास इस तरह से हर 10 कीज के बाद एक सेम की जनरेट होती है, ठीक है, तो आपके पास क्या होगा, पैटर्न जनरेट हो जाएगा। अब जब पैटर्न जनरेट होगा तो यूर अटैकर कैन इजीली डिटरमाइन कि आफ्टर 10 and the key is generated which is similar to the first one. So this is going to give some clue to the attacker and he can compromise the system. He can predict, we can predict, attacker can compromise the system. So in order to overcome that particular problem, we are adding an other set of value that is called as your initialization vector. Now IV is going to randomize more, ठीक है। अब पहले की स्ट्रीम था, की स्ट्रीम के साथ की ऐड हुई, की के साथ अब हम क्या कर रहे हैं, आईवी को ऐड कर रहे हैं। अब आईवी ऐड करने से क्या होगा, आपका सिस्टम जो है दैट वुड बी मोर रैंडमाइज एंड द वैल्यूज व्हिच आर बीइंग जनरेटेड वुड नॉट बी जनरेटिंग एनी टाइप ऑफ पैटर्न, और जब वो पैटर्न जनरेट नहीं होगा तो इट वुड बी वेरी डिफिकल्ट फॉर एन अटैकर टू कॉम्प्रोमाइज योर सिस्टम, राइट? So providing attackers with these types of patterns can make their job easier in breaking the encryption method and uncovering the keys, right? ये इसकी एग्जांपल है IV की। For example, if we have the plain text value of C spot run 2 times within our message, we need to make sure that even though there is a pattern in the plain text message, a pattern in the resulting cipher text will not be created. ठीक है जी। So the IV and key are both used by the algorithm to provide more randomness to the encryption process. तो आपके पास अगर C spot run का एक मैसेज है जो 2 टाइम्स रिपीट हो रहा है टेक्स्ट के अंदर, तो डेफिनेटली अगर आपके पास IV नहीं होगा तो रिजल्टिंग टेक्स्ट के अंदर भी वो पैटर्न रिपीट होगा और यूर your attacker can easily get the information and can compromise your system. But if you are using the IV and key both as inside your algorithm as a randomized values, so it would be very difficult for the attacker to compromise your system, right? So this was the example. अब ये इसके characteristics हैं, ठीक है जी, right? So characteristics आपके पास क्या है? I mean, let's suppose if you want to say that कि आपका cipher जो है वो strong stream cipher हो, तो you must have long periods of non-repeating patterns within the key stream values. आपकी जो key stream values generate हो रही हैं उनके अंदर patterns नहीं repeat होने चाहिए, repeating values नहीं होनी चाहिए, ठीक है? उसकी explanation क्या है? Your bits generated by the key stream must be random, right? Second point क्या है? Statistically unpredictable key stream. The bits generated from the key stream generator cannot be predicted. I mean, whatsoever the bits which are being generated by the key stream, one cannot predict them, right? One must not say them कि जी अगर 4 ones generate हुए हैं तो 4 zeros generate हो रहे हैं, again 4 ones generate हो रहे हैं, तो next जो value होगी ना वो again 4 zeros ही होगी, ठीक है? So that must not be the case. Third point is a key stream not linearly related to the key. ठीक है जी, आपके पास जो की स्ट्रीम है इट मस्ट नॉट बी linearly related with the key. If someone figures out the key stream value, that does not mean she knows the key value. ठीक है, अगर आपको की स्ट्रीम मिल जाता है तो इट डजंट मीन दैट कि आप उसमें से की भी निकाल सकते हैं. तो आपकी की स्ट्रीम में और आपके की के साथ कोई लीनियर रिलेशनशिप नहीं होना चाहिए, ठीक है. एंड द फोर्थ पॉइंट इज स्टैटिस्टिकली अनबियास्ड की स्ट्रीम. आई मीन एज मैनी जीरोस एज वंस आर. So there should be no dominancy in the number of zeros or ones in the key stream. ऐसा भी नहीं होना चाहिए कि आपके पास zeros कम है और ones ज्यादा है, ठीक है, और आपके पास ones ज्यादा है zeros कम है. I mean, no any pattern sort of thing must be generated from a given text of values, right? ये अब आप पढ़ लीजिएगा स्ट्रीम एंड ब्लॉक साइफर इंप्लीमेंटेशन कैसे होती है, ठीक है. स्ट्रीम साइफर वर्सेस वन टाइम पैड, ये भी मैं आपको बता चुका हूँ. यू हैव टू रीड इट. नाउ द वेरी इंपॉर्टेंट आइडिया, right, that is called as your hybrid encryption system. Now see, I mean, आप लोगों को पता है, you know that symmetric algorithms have certain pros and cons. Asymmetric algorithm have certain pros and cons. Symmetric के क्या advantages और disadvantages हैं? Symmetric are faster, they are less complex. What are the disadvantages of symmetric algorithm? The distribution of key is overwhelming. ठीक है, आपकी जो key distribution है that is a very difficult process in symmetric algorithm. Now come to the asymmetric algorithm. Asymmetric algorithm are they do not have a problem of key distribution. They have the public private key pair, so it would be very easy. आपके पास key distribution का problem solve हो गया. लेकिन at the other hand, it is, I mean to say that slow, right? And when it is slow, definitely it would be very difficult to be implemented, right? Now, in any situation, no single solution can be implemented. अब ऐसा नहीं हो सकता कि हम कहें कि जी for all scenarios, I mean symmetric को ही apply करना पड़ेगा, and for other scenarios asymmetric apply होंगे. I mean, no any scenario that can be fully implemented. So to overcome that particular problem, we need to have a central solution or the centralized solution or the medium solution हम जैसे कह सकते हैं या middle solution कह सकते हैं. That is called as your hybrid encryption system. What does it mean? It means that it would be using some part of your symmetric algorithm and another part of your asymmetric algorithm, and by using both of these, it would be designing a medium solution that is called as your hybrid encryption system. And this is very best and it can be applied to in all situations, right? अब ये कैसे होता है इसकी मैं थ्योरी नहीं पढ़ रहा, आपको मैं थ्रू डायग्राम समझा देता हूँ. Now see, we have party A and we have another party that is B. They want to communicate, ठीक है. अब ये सिमेट्रिक के थ्रू भी कर सकते हैं, asymmetric के थ्रू भी कर सकते हैं, लेकिन we need to have a hybrid encryption scheme, right? So what we need to do in the first step, we need to create a symmetric session key. ठीक है जी, ये symmetric session key का मतलब ये हुआ कि हमने symmetric algorithm की क्वालिटीज को अप्लाई किया. Symmetric session key क्रिएट हो गई, that would be lying down with the sender, and we need to transfer to the receiver in order to encrypt and decrypt the data at both the ends, because in symmetric algorithm the key is the problem to send to a receiver. ठीक है जी, तो उसको आपने किसी दूसरे वे से भेजना है. अब उस वे को हमने कैसे ढूंढना है? That is through the asymmetric cryptography. Now in second step, what he is doing? He is saying that encrypt session key with parties B's public key. अब यहाँ पे पहले स्टेप में हमने क्या किया? हमने सिमेट्रिक के कैरेक्टरिस्टिक को यूज करते हुए हमने सेशन की क्रिएट कर ली, दैट इज अ सिमेट्रिक की, राइट? अब आप सिमेट्रिक को भूल जाएं. नाउ यू हैव टू अंडरस्टैंड कि जी अब हमने वी नीड टू यूज एसिमेट्रिक प्रॉपर्टीज. अब एसिमेट्रिक प्रॉपर्टी क्या कहती है? पार्टी ए हैज वन प्राइवेट की एंड its public keys are available over an internet. Party B has one private key and its public keys are available at the internet. तो पार्टी ए को पार्टी बी की पब्लिक कीज का पता होगा और पार्टी बी को पार्टी ए की पब्लिक की का पता होगा, राइट? नाउ व्हाट वी आर गोइंग टू डू, वी आर गोइंग टू encrypt that session key that we have created in our first step by using B's public key. ठीक है, आई बात समझ में? हमने क्या किया, पार्टी बी की पब्लिक की के साथ अपनी सिमेट्रिक सेशन की को एनक्रिप्ट किया, राइट? नाउ दिस की इज encrypted, we can send over a public internet. I mean, there must not be any problem because it is fully confidential and that particular key is only being reopened by the person who can possess that particular private key जो उस public key के साथ थी. ठीक है, अब जब ये key आपके पास पार्टी B के पास पहुंची, so send the symmetric session key encrypted for confidentiality, and when it receives at the receiver's end at party B, तो पार्टी B is going to decrypt that particular session key with its private key. क्योंकि पार्टी B के पास तो उस पब्लिक की प्राइवेट की है ना, उस प्राइवेट की को यूज करते हुए वो आपके पास उस पब्लिक की को आई मीन उस सेशन की को डिक्रिप्ट करेगा. एंड नाउ दैट पर्टिकुलर सेशन की इज विथ पार्टी B. अब देखें, आई मीन पार्टी ए के पास भी सेशन की है, पार्टी बी के पास भी सेशन की है. नाउ दे कैन कम्युनिकेट यूजिंग सिमेट्रिक एल्गोरिथम और सिमेट्रिक इंक्रिप्शन. और नीचे हमने की को ट्रांसफर कैसे किया? बाय यूजिंग asymmetric mechanism. So we have used both the situation in a single solution, and that particular solution is being called as your hybrid key algorithm, right? And the fifth is saying subsequent encrypt with symmetric session key. और फिर बाकी जो encryption आपके पास होगी वो symmetric session key के through I mean to say that transfer आपका data हो रहा होगा. ठीक है, so this is the basic idea of I mean to say that hybrid encryption system.